Well, our topic is the graphing of rational functions. And by the way, a rational function has the form r of x equals, and it's a quotient of polynomials, p of x over q of x. Now, as to graphing a rational function, we're going to work off a fundamental equation and its graph. We're going to talk about domain and range and how they relate to the vertical and horizontal asymptotes. We're going to determine intercepts, and then we're going to actually graph these three rational functions. So let's start off with a fundamental equation, and we'll keep it simple. And our fundamental equation will be f of x equals 1 over x. Now let's determine the domain of this thing, and the domain equals the set x such that, and since division by 0 is undefined, x cannot equal 0. The range equals all the y values that can be attained, but there's one y value that can't be attained, and that's 0. The only way f of x could be 0 is if the numerator can be 0. Since the numerator is 1, f of x can never be 0, so y, which equals f of x, can never be 0. Now let's talk about the vertical asymptotes. So the vertical asymptote is that, well, what value has been excluded from the domain? 0 has, so x equals 0. Notice the relationship between the domain and the vertical asymptote. X has been 0 has been excluded, 0 is included, or is the vertical asymptote. As far as horizontal asymptotes, they are the y values, or the y value that f of x approaches as x gets extremely large or extremely small. Consider this: if x was 10, we'd have 1/10. If x was 1,000, we'd have 1,000th. If x was 1,000,000,000, we'd have 1,000,000,000th. Aren't we approaching 0? I mean, that number is getting increasingly smaller and smaller. So we are y equals 0 is the horizontal asymptote, and that would hold true too if we were going in the opposite direction. Let x be negative 10, negative 1/10. Let x be negative 100, negative 100th, and so on. Now, as to the graph, x and y, and x is positive, so if x is positive, then f of x is positive. If x is negative, then f of x is negative, and there's our fundamental graph, and we will be moving that side to side and up and down in order to graph the equations above. Now we'll graph the rational function f of x equals 1 over the quantity x plus 4. First question, what's the domain of f of x? Well, it's all reals except negative 4. So x cannot take on the value negative 4. Otherwise, we would have division by 0. So then what's the vertical asymptote? That's going to be x equals negative 4. How about the range? Well, f of x can never be 0. And so the range is all reals but 0. Another way to consider that is this: if the degree of the numerator is less than the degree of the denominator, then the range will always be y, not all reals but 0. Y can't equal 0. And what's the horizontal asymptote? Y equals 0. Next, let's consider the the intercepts. So f of 0 equals 1/4. So our y-intercept is at 0, 1/4. On the other hand, there are no x-intercepts because f of x can never be 0, so there are none. Now let's graph this fellow, and x and y, and here we are out at -4, and we've got a vertical asymptote at -4. And the shape, notice we just have a horizontal shift, so our shape is the same, it's just been moved to the left. And the intercept, y-intercept, is at 0, 1/4. And we're done. Now we'll deal with g of x, and with g of x we have a vertical shift. So let's just consider the domain, and the domain's all reals but 0, so x can't equal 0. Now we'll consider the range, and what if this 4 wasn't here? We already know the range is all reals but 0. So we've excluded 0. Let's add 4 to 0. Now it will be all reals but 4. So y can't equal 4. We've shifted this graph up 4 units. So the vertical asymptote is at x equals 0. The horizontal asymptote is at y equals 4. As for the intercepts, well, there are no y-intercepts since the vertical asymptote is at x equals 0. None. On the other hand, as for x-intercepts, well, what we'll do, we'll set g of x equal to 0. That is, we'll set 1 over x plus 4 equal to 0. And if you solve that, you'll wind up with the solution x equals -1/4. So we have an x-intercept at x equals -1/4. Go ahead, please solve that and verify that you do come up with this x-intercept. So now let's graph our friend here, x and y, and we've moved it up 4 units. So here's our horizontal asymptote, and 0, 4. And now the shape remains the same. It's simply been moved up, and there's our horizontal asymptote at 4, vertical asymptote at 0. And our x-intercept is at -1/4, 0. And we're ready to move on.